Everybody. Hey, you excited for the eclipse? I don't know. I didn't hear any excitement. Are we excited for the eclipse? I am Sarah. I am a doc services assistant at Clearview Public Library. Welcome to the new Severance Library as well. We are here today with Emily, an aerospace engineer. Really fancy title, I know. Who will be talking about the eclipse. During this, around 11:15, we might be able to see some shadows, but don't worry because we won't see totality for quite a while. So if you stay in here, I am going to open the doors, which might make a scary sound, just to warn you guys. But you're able to come in and out, and we do have refreshments in the back as well, juice, cookies, sandwiches. So feel free to help yourself. And then otherwise, I'm gonna go ahead and ask you.
Awesome.
Emily, you can take it away.
Are you gonna do this?
I'm gonna open the
wait
door
for them real
real quick.
quick. Okay, brace for scary sounds.
Brace. Right? Right? Just gonna stand you for a minute. I know. There we are. Okay, go ahead, Emily.
In the cold air too. All right, everyone. I'm Emily. I am, as Sarah mentioned, I'm an aerospace engineer. I have been for about a year and a half. Prior to that, all of my background is in astronomy. Specifically, I was studying stars. I was studying stars that would go in orbit around each other, which is sort of like the eclipse, but we'll get into that all a little bit more later. I'm trying to think real quick. I think that's all the background you guys will need, but if you have any questions at any time, feel free to raise your hand, call out. And also, if at any point you have a hard time understanding me or I'm a bit too quiet, just let me know. All right. Whoop. It's fighting back. There we go. All right, so what we're going to be talking about today is I'm going to jump into explaining a little bit of what the eclipse actually is. We'll define the eclipse. We'll talk about lunar versus solar eclipse, which we're going to be seeing a solar eclipse today. And then also we'll talk a little bit about totality. I'm sure you guys have heard that a lot. You may or may not know exactly what that is. That's often the pictures that the news will broadcast all the time. We are not in totality today. But we still will get some pretty good coverage. That's 65%. Again, I'll explain that all a little bit more once we get to that. After that, we'll launch into exactly what we'll be seeing today, some fun things that you can keep an eye out for, and kind of different ways that you can observe it. Because of course you can look at it with your glasses, with the fancy cool glasses. Or there's some other fun ways of you look at shadows, you look at colors and such, and those all usually get a small effect as well. All right, so launching into it, what exactly is an eclipse? The eclipse itself is just a way to say it is an object passing in front of another object, blocking out some of that light. So up here, for an example, I have people kind of hanging out by a fire, passing in front of it, maybe walking back and forth. If you're sitting behind the people, that fire is going to dim for you a little bit. You'll have their shadows in front of you. There'll still be light around you. You'll still be able to see, but won't be nearly as bright as if you're looking directly at the fire. That is fairly similar to what the eclipse is. So when something passes in front of the sun, you get a shadow casting from it. So you'll get to that slight dimming as it goes across this total path. But of course, if it's only halfway blocking the sun, sorry, I forget to breathe. It's a thing. I'll catch my breath as I go. If you're only blocking it halfway, it's going to be brighter than if you're blocking it completely. So that's where you get this nice smooth dimming and brightening as an object first goes to cover it and then moves off of it as well. So launching a bit further into it, we have lunar and solar eclipses. So these are same exact concept. You have something blocking a light source, so you're getting that darkening from it. But we have two different objects that can block our sun. First of all, we have the moon, which can pass above the sun, but also the earth can pass above the sun and block the light that usually hits the moon. So up here, what you're seeing is I created these if I can find my laser pointer. So not too well, so I'm just going to point really well. So what you're seeing up here is I'm creating those kind of projected lines that are showing where a shadow would go. Obviously, it's not to scale, but you're able to see this shadow coming off of on your guys' left-hand side. The shadow is coming from the earth. So the earth is in front of the sun and the moon is passing in the earth's shadow. Then on the flip side, you have the moon is passing in front of the sun and you have a shadow from the moon projected onto the earth. Now, as you can see from these little lines, the earth is a much bigger object than the moon. So the shadow it makes is also a lot bigger. So it's a lot easier for the moon to then pass through that shadow and become completely covered. However, with the moon being smaller, it creates a much tinier shadow. So you create, but that's like that little dot hitting the earth, that would be where its shadow is, passing the earth. So now if you're standing in that little dot, then it's going to completely block out the sun. Not quite completely, but pretty close. You'll see the entire shape cover the sun. However, if you're standing off to the side of that shadow, it's not going to completely cover the sun. You're going to be able to see around the moon. So that is, I'm going to see if I can exit out of that real quick.
I'm here.
There we go. Someone showed up. I figured if I pressed enough buttons, someone would appear.
Sorry, guys, technical difficulties. We're trying to get them signed in. Is this too far or too?
I can click back to where I need to be.
Okay.
Don't worry about it.
They're trying to get Windsor connected to us. So you guys are getting the prime deal here.
All right. Sorry, remember exactly where I was at. So we talked about the shadows coming off of either the earth or the moon. When you have the earth shadow projecting on the moon, that is what we call a lunar eclipse. Sorry, I remember exactly. It's easy to get them mixed up, right? Because in both cases, we have the moon and the sun. You have solar and lunar. But the lunar is within that shadow, or within the shadow of the earth, versus the solar is the moon's shadow hitting the earth. You have the sun being blocked out by the moon. So today we are seeing the solar. We do have the moon is heading into the path of the sun. So it's going to be blocking the sun from our point of view. I'm going to click ahead here because this is where I'm going to talk a little bit more about shadows too. So I mentioned before, you have the moon shadow projecting onto the earth. If you stand that shadow, you won't see the sun. The sun will be blocked by the moon for the most part. Sorry, keep adding that little caveat because the moon is, like we said, it's pretty small relative to the size of the earth and the sun. So you won't be able to see the sun poking out from behind it. But in our case, we're not standing directly in that shadow. We're going to be off on the side of it. So we're going to still be able to see that sun poking out for the most part. We get 65% coverage is what they call it. So 65% of the sun is going to be blocked by the moon. So what I'm talking about up here exactly is using the example of a shadow puppet, because I'm sure we've all kind of played around with some sort of light source, a flashlight, a phone, and you move your hand across from it, you make all these fun little figures like little doggies barking along. Exactly. And as you move your hand in front of the flashlight, the shadow moves along with it. Now the shadow usually will cover this much larger space than just your hand. You can make those tiny little movements in front of the flashlight and the shadow will arch these huge spaces. That's about the same as with the moon blocking out light from the sun. It doesn't have to cover necessarily this whole long distance in order for its shadow to then arch all the way across the earth. So here, if you think of having two little flies on a wall that you're projecting your shadow puppet, your little puppy on, one of those flies is hanging out in the shadow of the puppy. So it's going to be completely blocked and you won't be able to see that flashlight at all, or the fly won't be able to see the flashlight when it's covered in the shadow of the puppy. versus fly number 2, sitting just a little ways off, we'll still be able to see the flashlight. So with I am not an artist, I am an engineer. So my beautiful pictures up here, I have roughly illustrated, very roughly, fly number 1 sitting in the shadow will just see your hands. It'll see the hand in front of the flashlight. Versus fly number 2, just a little bit off outside the shadow, we'll still be able to see your hands, but also we'll see the flashlight poking out from the side of it. It won't have a completely blocked flashlight. That's what we call partial coverage, because it's only partially covering the light source. All right, here's a picture I'm sure you've seen on the news plenty by now. This is showing exactly where the path of totality is, which is a fun way of saying where the shadow is going to be racing across the earth. So to break down a little bit more, because we always see this picture, but not too often is it broken down and explained exactly what is going on. Over here on the left, we are seeing where the shadow is going to be relative to what times. So that little X, that roughly marks where we are. So we are not going to be in that path of the shadow. We are a little ways off. But then Austin, Texas down there, they are completely in the shadow. So right now, I think you guys kind of have prime viewing in a way, because big crowds like to gather exactly where those shadows are going to be. Versus we have plenty of space to move and see the shadow without finding all those big crowds. All right. And then over here on the right-hand side of the screen, that is showing what those partial coverages is. So if you're thinking back to that flashlight and hand shadow example, how much of the flashlight are you actually able to see corresponds with how much the opposite of the covered, how much of it is left uncovered. It's okay, I press X.
Yeah,
You got it.
go ahead and press your finger right.
All right.
Like I said, you guys have prime viewing.
There we go. All right. So that map on the right, showing those gradients, as you get further and further from where the base of that shadow is, you're able to see more and more of the light source. You'll see more and more of the sun poking out from behind the moon. We're around 65, which, as I was saying, it's still pretty good coverage. It's enough that you will notice a difference, but not quite enough to be a significant change. You'll see shadows change shapes. You'll see maybe a little bit of dimming, nothing too significant. And with your fancy cool glasses, you will be able to actually see the moon blocking the sun. All right, so now that we know exactly what's going on, what the eclipse is, we can talk about what you'll actually be able to see, which I've been alluding to a little bit. But first, what we have up here is the exact breakdown of those times for you, of when you'll be able to see it. So beginning roughly at 11:30 is when the sun first gets a little bit obscured by the moon. So just barely that sliver starts marching its way across. It will steadily move across until around 12:40-ish is when you'll get maximum coverage. So that 65% being covered, just past halfway, will be at 12:40. And then from there on, it'll start just reversing itself. It'll slowly move away from the sun, slowly move off the sun, and it'll start getting, the sun will get brighter and brighter again until it goes back to normal. Across the bottom here is just a rough example of exactly what I'm talking about when I say the shadow's blocking the sun or the moon's blocking the sun. It's going to be kind of arching just off the side of it, not quite lining up perfectly with the middle. So you'll see in that middle there, that will be like the maximum coverage. Again, this was just a quick Photoshop job. It is not exactly what you'll be seeing. But you'll see that marching until it reaches max coverage, but won't quite block out the sun in its entirety. And they'll go back on marching on off as we return to normal. I also made the little comparison. You can't quite see it, but up in that right-hand corner, we are fly number 2, the fly that wasn't completely in the shadow. All right, so now for what I think is the really fun part, which is the less traditional ways to view it. Because of course, you will have your little solar glasses. You can use the solar glasses to look at the sun. please do not look at it without the glasses, because the sun is still the sun. You should never look at it. It's quite bright. But otherwise, there's also fun ways of being able to look at the shadows. Anything that's peeking out of holes, we call these pinholes. So looking through the leaves of a tree or a calendar, or you can even play with your hands. I like to kind of weave your hands so you get little gaps in between. And if you look down at the shadow, you'll get these kind of cool crescent shapes, which I believe yep, there we go. Y'all get, yeah, that's my cat. Her name is Newt. She's quite cute. She's really soft. So these little crescent shapes, those are a side effect of the eclipse, of the image being projected out, which, sorry, let me figure out. This is one of those little more complicated parts, which I'm going to break down as best I can. But if it's a bit confusing, feel free to ask questions, or even I'll hang around a little bit. You can come find me and ask more questions. But you essentially have this big image being projected, right? If you think of a light projector, all this light coming out, creating an image, maybe an image of my really fuzzy cat Newt. But because it's being projected so far, it gets kind of blurry. It gets a low resolution. But then if you were to create a small sliver.
Code for a second.
Sorry, people are talking to us. Don't mind the voices. If you then create a tiny little hole for that light to go through, it essentially resets that resolution. So it starts shining out of this hole again, and you get this much tinier image coming out. Now, we aren't projecting any actual image. It is just light coming from the sun, pure light. But that means that you can see kind of the original shape it's coming from. So then these little crescents, that's because that was the original shape it was coming out from the source, from the sun as the sun is no longer an actual sphere, it is a crescent being made by the moon in front of it. So hopefully that makes a bit more sense. We call these pinhole projectors. They are something really fun that you can do at any time, not just during the eclipse. With if you use an old cereal box or something, you can find some really fun tutorials online. They are, as a physics major, as an astronomy major, I made these before, and they are really fun to mess around with. All right, now that is all I really have right now. Just another little shout out to please don't look directly at the sun. The reason we have the eclipse glasses is because the sun is so bright, you have essentially a filter to put in front of your eyes to keep it from being blinding, literally blinding. We even, when using telescopes, when you're making observations, they will point telescopes at suns, but you can't look directly at them because either the eye inside the telescope, or sometimes we have a camera looking down telescopes too. Those can be broken and destroyed by the pure brightness of our sun. So we use essentially the same thing, a really dark filter that makes everything else in comparison completely black. You won't be able to see anything else except for this single source shining through. You can do the same with your camera. I recommend being really careful if you do that, as it can hurt your camera still to take pictures of the sun. And it's a bit tricky making sure that you don't look at the sun as you're trying to get your camera pointed just right. So just be careful, but enjoy just the changing of our Earth, this kind of rare astronomical event. You'll hear Sarah mention it. I think you already did once. This only happens in our relative area, happen other places on Earth, but not that we can see. For us, the next one that we'll be able to observe from the United States is in about 27 years. 21 years, so she's got it. All right. Feel free to ask questions. I might rush through that a little bit fast. But I enjoy talking about this all way too much. So if I let myself ramble on, we'll be here for hours, and I don't think you guys want that today. So, any immediate questions? All right, then I'll go ahead and pass it back off to Sarah.